Hey guys, Travis Gillespie here. In the last section we were looking at linear equations, and now I'm going to jump into functions. I just want to take a quick review. We looked at different forms of linear equations, and I'm actually going to steal one of these linear equations or borrow it as we jump into the next section on functions. So what I need to actually do is just, I'm going to make a copy of this information right here. I'm going to paste it on the screen and just let's slide that over here. All right, so I have slope intercept. In fact, let me get rid of that. And I'll probably actually need to just slide this down some. I want to make some other notes. All right, so far we've been looking at equations. And soon and in fact, in this section, we're actually jumping into functions and looking at functions. And before we even look at functions, or before I even jump into it, I really want to look at, well, what's the difference between the two of these? What's the difference between an equation and a function? So I'm actually just going to start by defining both of these. All right, so an equation, it's any statement that two expressions are equal. So a statement that two expressions are equal. Fix that x. Expressions are equal. So if I look below here, the equation for slope-intercept form, y equals mx plus b, well, it's stating that, well, this expression, y, is equal to this expression, mx plus b. Or below, this expression, y, is equal to negative 4/3 x plus 3. All right, so an equation, two statements are equal. Well, what about a function? Well, a function is a relationship between two variables. So I'm just going to write that down first, and there's more to it than that, but I just want to get that part down. So a relationship, and fix that I, between, fix that W, two variables. Okay, so this is the first part of it. It's a relationship between two variables, but I'm going to add to that. So a relationship between two variables that any value of your independent variable, so I'm just going to say so that your independent variable has only one dependent variable, and I'm going to add some information to independent variable, but your independent variable has, fix that S, has only one, so has only one value for your dependent variable. Has only one, in fact, I'll put value there, value of your dependent variable. Okay, so whatever the value is for your independent variable, it has only one corresponding value for the dependent variable. So there are some other ways I can look at this independent and dependent relationship here. So some other terms I could use for independent variable, well, you could think of it as your x value, or x, or think of it as the input. It could also be the input, or the value in the domain. So the x value, the input, or the value in the domain. And for your dependent variable, some other terms you can think of it as is, well, it's your y value, or your value for y. It would be the output. So if you have an input for your independent variable, well, then you have an output. Or you can think about it as the values in the range. All right, so I'm not going to write out a function yet. I still want to go back to equations, and then we're going to build over to functions after that. Okay, I'm going to delete some of this information. Just remember that M represents the value for your slope, B represents the value for your y-intercept. So taking that information with us about M and B, well, bridging from an equation to a function is pretty simple from there, because an equation can actually define a function. Okay, and if I were to actually take the information here that helps to define a function, well, it actually it turns out that this equation can be a function. So although we can think of this equation as stating that, well, y is equal to whatever's on the right-hand side here, in this case, -4/3 x plus 3, this is also stating that y is a function of x, or y depends on the value for x. Well, it turns out that most linear equations are functions with the exception of a vertical line. So what if I had x is equal to 4 here? Well, if you were to actually graph that, I'm not going to go into full detail, but if I were to actually graph that, it would create a vertical line. And what this is saying is, well, I have a value for x. It's constantly x, or x, it will always be 4. And it has multiple values for y. So here's my input. My input for x will have more than one y value, or more than one output. And if we look at a function, the definition says, well, we can only have one output. We can only have one output, but in this case, a vertical line has multiple outputs for the same x value. So in fact, if I actually look at that, I want to just redefine it. The independent variable, whatever your value is for x, in this case 4 should only have one value for y, or its output, but over here we're seeing that the input 4 for x has multiple values for y. It creates that vertical line. However, I have a straight line, so this linear equation here is not a function. So this is the exception to the rule, and in fact, let's just delete it. I'm going to get rid of it. So this linear equation here, this equation can be written as a function. In fact, this is a function. So what I'm going to do is just copy it and drag it over to the function side. It is an equation, but it's also a function, because if I were to substitute values in for x, or x into the equation here, let me get rid of that. If I were to substitute values in for x, each value for x would have only one value for y. So again, although I'm stating over here, I'm stating y is equal to the information on this side of the equation, over here I'm stating that y is a function of x. The value for y depends on the value for x. Alright, so what I'm going to do here is I'm actually going to write another equation down, y equals, let's say y is equal to x plus 2. I just want to keep it simple right now. So y equals x plus 2. I have an equation here, and it turns out that this equation is actually a function. So we'll get that information, copy it, and just drag it on over. So you could read this as y equals x plus 2. Or another way of stating that is y changes as the value for x changes. Or another way of stating it is y changes according to the value of x, or y changes according to x. So what I'm really saying here is y is a function of x. So what I'm really getting into is something called function notation. You might see this symbol every once in a while, f of x, and that's how we would say it, f of x. So this is function notation. I'm going to come back to it. I just want to go back to the equation over here. Well, a minute ago you heard me say that, well, y is a function of x in this equation here. So in fact, if you actually thought about that and you wanted a visual of it, well, in fact, I need to erase that f. You would say, well, y is a function of x. Y is a function of x. And that's how you could actually visualize that. But I want to get back to this equation again. Well, since this equation is also a function, well, y is naming the function here. And we could write this as, well, as a function, y equals x plus 2. We could write it that way. But some people like to use this symbol, which I'm going to get into. I'm realizing I want to slide this down. Well, you've heard me talk about this function a few times already, and I'm just going to read it one more time. Y equals x plus 2. That's a perfectly acceptable way to write this function. Others would say, well, since y is a function of x, and the way I would actually state that is y of x, I'm going to actually write that over here. They say, well, why not denote that we have a function y of x here? So we're denoting that y is a function of x right here, and that's equal to x plus 2. So what we're actually seeing here is that these two functions, although they're written a little bit different, they're actually stating the same thing. They're the same function, just written a little bit differently. And what some people actually will do is they'll replace the variable, or this letter y here, with an f, and that's what I'm actually going to do too. And in fact, let's just slide that over. In school, you're typically going to see a function written as f of x, so you'll be looking at most functions written as f of x is equal to x plus 2. But again, although this function is written a little bit different than the functions above, all three of these functions are stating the same thing, that y is a function of x and y is equal to x plus 2. In fact, another way of thinking about f of x is the same thing as y. It's the same thing as y here. So again, whenever you see f of x, another way of thinking about it is just thinking about f of x as the variable y. So whatever the value is for that input x, you're going to find its corresponding output value for y. So now I'm going to get rid of this information. Now all three of these equations, they're stating that y changes as x changes. And this is why people use y of x or f of x rather than simply using just y, because you're clearly stating that y is a function of x. So whenever you see this symbol f of x, don't be intimidated. So whenever you see this symbol in an equation, well, just know it's known as function notation, and it's stating that that equation is a function. And I actually want to talk about one more thing. Alright, so the last thing I'm going to talk about here, y is the dependent variable of x. X is the independent variable, and that tells us that f of x depends on whatever x is or whatever variable you're using in the problem. You might be looking at a problem that deals with time, and rather than using x as your variable, you might use t as your variable. So in that situation, you would probably use something for your function notation like f of t, and this is just telling us f of t in that problem. If it's dealing with time and your variable is t, well, f of t depends on whatever your variable for t is in your problem or your equation. So f of t is equal to, let's just keep this simple, t plus t. In fact, I'm going to fix all that information. T plus 2. F of t depends on t in this situation. All right, so just to recap, an equation, it's any statement where two expressions are equal to one another, and equations can be written as functions as long as you have a relationship between two variables where your independent variable has only one value for your dependent variable. Cool stuff. I'll see you in another video.